Now that we know how to graph square root functions, we're going to simplify some of these radical expressions. And the awesome thing about this is we're not going to simplify it with decimals. We're going to simplify that and leave things in radical form. So by the end of this lesson, you should be able to simplify radical expressions. Radical expressions do not have an equal sign. If they did, they'd be called radical equations. So make sure you're paying attention to that. These are two examples of radical expressions here, and they both contain a radical. What we're going to do is simplify it by removing perfect square factors from what's underneath. So remember, the radicand is the thing underneath. And we're going to do that using these two properties here. The multiplication property of square roots says that you can turn any number into factors and then take the square root of those factors. So to get 54, we'd multiply 9 and 6, and I know the square root of 9 is 3, and the square root of 6 can't be simplified anymore. We can do the same thing with division. So something like 16 over 25, instead of taking the square root of that whole number, I can take the square root of 16 and the square root of 25 and get 4/5. So what would be really helpful for you is to memorize the perfect square factors. I'd say at least up to 12. So I'm talking like 1, 4, 9, 16, 25, 36, 49, 64. That's 8. So then the next one, remember, I'm doing just like 9 times 9. 100, 11 times 11 is 121, and 12 times 12 is 144. I would definitely say to have these memorized. It'll make your life a lot easier. So let's use the multiplication property to rewrite these. So what you're going to do is you're going to ask yourself, what numbers multiply to make 50? And you want one of the numbers to be one of these perfect square numbers here. So chances are 5 and 10 popped into your head, but 5 isn't a perfect square and neither is 10. So let's try some other ones. 2 and 25 are. So I can break this up into 2 times 25, and then the multiplication property says I can take the square root of 25 and multiply that by the square root of 2, which gives me 5 root 2. This right here is the simplified version of the square root of 50. Now we can do the same thing over here with this one. Find two numbers that multiply to make 300, and you want one of them to be a perfect square. So 100 is going to be the one that wins that. And this is really 100 times 3. I know the square root of 100, and I don't know the square root of 3, which is okay. The square root of 100 is 10. And then I have to remember that this is just multiplying out here, so I'm just going to multiply these two together and get negative 50 root 3. That's as simple as it goes. I'm going to leave this last one for you to do on your own. So let's try some things with letters. Letters work very, very similar. So what we're going to do first is we're going to split this up into the square root of 27 times the square root of n squared. So 27, find a perfect square that fits into it. 9 is the biggest one that fits into it, and it fits in 3 times. So when I take the square root of both of these, I'm going to get 3 root 3. And then n squared, remember, means n times n. And in order for something to be a square root, it means we have to have two of the same thing. So the square root of n squared is just n. And then unfortunately this isn't simplified. We have to combine everything that's outside of the square root with everything that's still inside of the square root. So this is the answer we want. Now with the next one, we have that negative a on the outside. Remember, it's just multiplying. So let's break it up into our numbers and our letters. Our numbers. Chances are you thought 30 and 2, not a perfect square. So keep breaking it up. 60 breaks into either 30 and 2. Our next smallest one would be, that's 3 and 20. Neither of those are perfect squares. 4 and 15. This is a perfect square. And 15 can't be broken down anymore. It gets broken down into 3 and 5, which neither of those are the same. So we know this is the biggest perfect square that goes into it. So what we're going to do is take the square root of both of those. Remember, we still have this negative a out here. Square root of 4 is 2. Square root of 15, I don't know. And then a to the 7th, you can think about it as 7 a's, right? 1, 2, 3, 4, 5, 6, 7. The square root means you have to have pairs before you can come out. So we can make 3 pairs here, or a cubed, and this guy doesn't have a friend, so he has to stay inside of the square root. So then before we're done, we got to combine everything on the outside. Remember, this is like a -1, so if we combine our numbers, we get -2. I have 1a over here and 3 more a's there, so that's a to the 4th. And then underneath the square root, I have a 15 and an a. I'm going to leave the last one for you. So now let's try ones like these, where they start a little messy. And when I look at the square root of 13 and the square root of 52, I don't know either of those square roots. So what I'm going to do is I'm going to take those two numbers and go backwards with the multiplication rule and actually multiply them together. So if we throw this in our calculator, we get 676. Now what I would suggest you do is every time you get something big like this that you might not be aware of, is double check to see if it is a perfect square. So if I type it in my calculator, the square root of 676, I actually get a nice pretty number. It's 26. And that's it. That's my answer. I'm done. Now if it wasn't a perfect square, then we would have to go through and find the biggest perfect square that fits into it. Like this next one. So I'm going to combine the stuff on the outside. There's just a 1 here, so 5 times 1 is 5. And then combine the stuff on the inside. So 3 times 6 is 18. C times C is C squared. And then I'm going to redistribute them out. Square root of 18 times square root of C squared. Square root of 18, hopefully you've done on your own in the first slide there. But the biggest thing that goes into 18 is 9. And it goes in there twice. So this is really 5 times 3 times the square root of 2. And then c squared, remember, means c times c. So that can come out of the square root. Squares and square roots always undo each other. Multiply everything on the outside together and everything on the inside together. And there we go. I'm leaving c for you. So we've done lots of multiplication. Let's do some division. So the first thing I would suggest is if the perfect squares are in your mind, you should get excited for this first problem here because both of them are perfect squares. You can do one of two things. You could break this up and take the square root of 144 over the square root of 9. Or you can divide those two things and see if you get another perfect square out, because sometimes that happens. And if you divide them, you actually get 16. Now I know the square root of 16 is 4, so I'm done, but if you didn't divide them, you could still do this. The square root of 144 is 12, the square root of 9 is 3, and 12/3 is the same thing as 4. Now one like b, there's nothing to simplify inside of here, so what I'm going to do is I'm going to break this up into the square root of 25p cubed divided by the square root of q squared. And I can do this stuff up at the top. Square root of 25 is 5. P cubed, remember, means you have p times p times p. So I can make one group of them, and one p has to stay inside the square root. And the square root of q squared, they just cross each other off, and I get a q. So this one is as simplified as possible. I'm leaving c. So let's try these. For this one, I do not know the square root of 90 or the square root of 5. So what I'm going to do is I'm going to simplify them first. And I get the square root of 18. Now this still isn't a perfect square, but it's one that we've done several times that we get 3 root 2 out of. So remember, that came from 18 is 9 times 2. I know the square root of 9 is 3, and the square root of 2 can't be simplified. So same thing with this next one, the square root of 48 divided by 75. Now this isn't something I know off the top of my head, and neither of those are perfect squares, so what I'm going to do is actually divide them. Square root of 48 divided by the square root of 75, and when we throw that into our calculator, if you simplify it, you get 16 over 25. 3 goes in, 3 goes into both of them. So then I know the square root of 16, and I know the square root of 25. Square root of 16 is just 4, and square root of 25 is 5. And that's it. So, one thing that can happen when we simplify these is we end up with a square root in the denominator. That is not allowed. So we have to get rid of this square root in the denominator. And in order to do that, we're going to do something called rationalizing the denominator. And in order to do this, you have to multiply the numerator and the denominator by the same radical expression. You want to choose a radical expression that will make the denominator a perfect square. So if I take a look at the first one, I'm just going to rewrite it so we have more room. I'm not allowed to have the square root of negative 3 on the bottom here. So what I'm going to do is I'm going to multiply the top and bottom by the same square root. Because what happens is on the top I get 3 times the square root of 3, but on the bottom I can multiply those together and I get the square root of 9. Now I know the square root of 9. That is just 3. And if you look, we have gotten rid of the radical in the denominator. And then you have to simplify this just like all the other ones that we've done. 3 divided by 3, those cross off, so this just simplifies to the square root of 3. Now with our next one, you can do several things. You could turn this into one big square root, but 5 divided by 18 isn't something we know. So you can approach this a couple different ways. What I would do is I would first simplify this denominator here. So if I just gave you the square root of 18t, we've done 18 a million times here, so hopefully you're getting the hang of it. Break it down into 9 and 2. It'd give me 3 root 2t. So this really looks like the square root of 5 divided by 3 times the square root of 2t. Now the 3 can stay in the denominator. It's totally okay to have numbers down there, but we can't have this. So what I'm going to do is I'm going to multiply the top and bottom by the square root of 2t. And the reason I have to do the top and the bottom is because then it turns into just a big giant 1, which is okay to multiply anything by. So on the top we got to combine those two things because they're both underneath the square root. And down here we still get this 3, but inside we get 4t squared. Now I know the square root of 4 is 2, and I know the square root of t squared is just t. So when I simplify this, I get this stuff on top divided by 6t. Now be very careful, you cannot divide the 10 and the 6 or the t and the t because on the numerator they're both inside the square root and on the denominator they're both outside. We cannot divide those. So I left a few for you to do, one on each thing. You need to go back and finish those. If you notice all of your directions say to simplify, you know something is simplified if these 3 things are true. The radicand has no perfect square factors, the radicand has no fractions, and the denominator doesn't have a radical in it. Make sure you write down any questions you have and we can go over them together in class. Enjoy your night.